My name's Daniel Lee, like I said. I work at EUMETSAT. We run the European Meteorological satellites. I'm not here with in any kind of EUMETSAT capacity. Instead, I'm here to talk about this topic. How do we get from data to knowledge, and perhaps beyond that even? We've been talking a lot about all these different things with data and AI and what we can do with them and how we can extract more value out of them. And so I'd like to ask you, here comes the crowdfunding part again, to give me some search terms. What are going to be the next really big things coming from big data and AI? And I'm going to write it down in analog fashion.
E-health.
E-health, okay. You first.
Augmented reality.
Augmented reality, okay. AR. Well, over here there was something.
Is solving search part of e-health?
Solving
cancer, sorry.
Solving
cancer.
Solving cancer, okay. Yeah, I'd say it's different. I'd say beat cancer, yeah. Because there are all kinds of algorithms involved in that. From the back left somewhere was something I thought I heard.
One-shot learning.
One-shot learning, okay. Any applications, or is it? Are you talking about?
So much faster learning algorithms for deep learning.
Mm-hmm. Okay.
Autonomous vehicles.
Autonomous vehicles. Avi, I don't mean audio video. Now I do. Okay, yeah. Autonomous vehicles. I'm exhausting my space here. Anybody got anything else?
Something that has to do with crossing the biology and AI.
Okay, so you're talking about the what's it called? The singularity. All right, the next big thing is the singularity. I can't even draw a singularity. Nobody can draw a singularity. Singularity, cat pictures. Let's see, there was pizza from the previous slides. Okay, I think we've collected enough catchphrases. So let's call that information. So these are a lot of really cool possible future things. Some of them are not future things. Some of them are already here, and we're working on making them better. And there's a lot of money going into this. So we've been talking about investment and having people pay you to develop these kinds of things. That's important too. I'm going to take us back for a short time to another big boom with a lot of hype from the past, and that takes us back to 1862. 1862 was a year when there was something really big that came out, and it was based on a lot of technologies all coming together in this nexus, and it was going to revolutionize the world. And this thing was called the Pan Telegraph for producing remote facsimiles. Does anybody know what a facsimile is? It's a fax. So you take something, you write it down with paper and a pen normally, and you make an exact copy of that. That is a facsimile. And the cool thing about the Pan Telegraph is that it was a telegraphic way of making these facsimiles. So you could make a copy from really far away using telegraphic technology. And all you needed was one of these huge towers. It was like that big. And you would set this thing swinging, and it would be swinging over a piece of paper that you'd written on. The paper would conduct electricity, the ink would not. And the thing that you have to do is you get another friend who has another one of these Pan Telegraphs. In this example, one was in Lyon, the other was in Paris. And over here you've got your friend, and his Pan Telegraph is swinging too, at the same rate. So you have to set them swinging at exactly the same time, and they form a circuit. So when the reading head of the Pan Telegraph in Lyon passes over the paper, and there's no ink blocking the electrical signal. It closes the circuit and causes the one in Paris to put some ink on the paper. That is how the Pan Telegraph worked. And people thought, wow, now we can make copies of all of our documents and send them to people really far away. It's faster than a horse. So for this reason, a lot of people started investing in this. And it wasn't just like normal telegraph business. Telegraphs had been around for a long, long time, for about 40 years at this point. And they hadn't caused the same boom as the remote facsimile had. The reason was because nobody wanted to be listening to dashes and dots. They wanted to have paper. They wanted to have information, stuff that they could work with. And so the Pan Telegraph was a lot more interesting. And fortunes were put into this and mostly lost because the tech just wasn't good enough. But we can see that typically for big technological transformations, maybe what was missing was some tech from another field to really make this marketable. So from the area of optical scanning came the possibility to not use this weird swinging head thing that was 2 meters tall, and instead use optical scanning. This came out in the 1920s, and that was pretty cool. Now you could make an optical scan of a piece of paper and transmit that somehow. And over time, this did not make faxes come into fashion, but it was an enabling technology to make piece of faxing technology more viable. So where you see on the left is a copier using an optical scanner, and the secretary is saying to, I guess, her boss or manager or whatever, I can make a copy in only 4 seconds with this machine. Or one that I really like is on the right, the radio newspaper receiver for home use. You could get the news twice a day with this thing. You'd sit at home and have this big box, and out of the box would come your newspaper, transmitted via radio wave. So that was like the 1920s to the 1950s. And around the 50s and the 60s, you started to have real business uses. So no longer any gimmicks like the newspaper transmission, but actual business use. So if you get one of these big machines you see on the left, you could scan in a piece of paper, and it would shoot out the other side. Not exactly that paper, that would be a teleportation, but a copy of that paper would shoot out the other side. And in a few years, it was really small and almost a status symbol to have a fax machine in your business. And this continued. Home usage came, so for mass consumers, the idea was you can send letters over the phone. You just need a little tiny machine and a phone and a modem for your phone, and you could write a letter and roll it up and send it to your friend as long as they have all the right equipment. And this is about the time when faxes really became standardized, where you had the fax protocol. So faxes from any manufacturer would work with the machines of any other manufacturer. Of course, the businesses knew that this was going to be big because everybody likes paper. You got contracts on paper, information, maybe your memoirs, whatever. And the telecoms industry really wanted to get this into people's homes. So here you see in the late 80s a fax machine, and it's been reduced by several $100s, so you can get it for only $1,500. 2 ads in the same newspaper right next to each other, and they're all over 1,000. It was big. And it was so big that eventually fax machines were even available in sports cars. Not just fax machines. This sports car, the Isuzu 4200R, had a tape deck, it had satellite navigation, and it had a fax machine. Does anybody have one of these? I imagine everybody with these are dead. Because if you're racing down the street writing a letter really quickly and then faxing it to somebody, you're going to die. But they were so cool that people wanted them in their sports cars. So that should tell you something. At the same time, in parallel to all of this investment in getting this technology into people's hands, there are some other people working, and we know them better today. This example is, I think, at IBM. They were working on computers, and what computers could do is transmit digital data. Basically, back to Morse code. So you might be asking, Why does anybody care about Morse code? Didn't we get rid of dots and dashes during the telegraph era? Yes, we did, because it's a stupid representation of data. But if you have a screen, you can take those binary information and display them any way you want. So suddenly, you can do things like, for example, transmit emotion or portray emotion in a very succinct way. You don't need paper for that. You just need some numbers that have a meaning behind them. In this case, ASCII symbols. And so the fax machine went the way of, well, the fax machine. And that may be very sad for the people who invested so much in making this a cool technology. But I'm not sad, and I imagine that most of us here aren't very sad about this. So what can we learn from this? You have a ubiquitous technology that fuels the world for thousands of years, and that is the representation of information on paper by having some marks on it, right? So paper is the medium, and paper is everywhere, and people wanted it. They used it for books. Oh, something I should mention, there even used to be in the early 90s, there was a service where you could fax in a request for information to a library, and a librarian would look up books and fax back the relevant pages to you. So, I mean, people wanted the internet, but they didn't know that they wanted the internet because they didn't have it. So they invested in fax machines. And here we are today. Data is everywhere. And I love data. Part of my job description is a data formats engineer, so I hope data doesn't go away, because then I'd have to go away too. But nonetheless, we're surrounded by data, and this data is supposed to help us do a lot of things. But as I'm sure most of you know, data is only interesting when you can do something with it. It's kind of like soil. You can do a lot of things with soil, but probably the most interesting thing you can do with soil is to grow plants on it, grow food out of it. I'm an ecologist by education, and so I like to think about colonization, pioneer plants, and that kind of thing. So whether or not you're from the environmental sciences, you'll be familiar with the term ecosystem. An ecosystem is when you have a bunch of different organisms working together to provide services that serve the ecosystem. So you might have a really cool rainforest with all kinds of monkeys and orchids and stuff running around in it. You might have a really cool app store that's making lots of money for you. What you need for any ecosystem, no matter what it is, whether it's a virtual or physical ecosystem, is complexity. And complexity comes from somewhere. And if we're using the same example again for data, I would say something happens. You know, I am going to use this. This is annoying to have my slides up there. So if something happens, that's here. It happens. That's H. Okay, and we're going all the way over to having a cool ecosystem. So the first thing that happens after anything happens is that it produces a signal. And if you take that signal and you interpret it or you record it somehow, maybe it's in your brain, maybe it's in a computer, that we can call data. And if you take that data and you can give it context and meaning, then we could call that information. And if you can use that information to optimize what you're doing, you might call it knowledge. Let's put K there. And beyond that, there are a few more categories too. There's insight. Now, this isn't from any textbook. This is my personal opinion. But I call insight knowing how to change your tactics. So you have knowledge that helps you act right now, that helps you do what you are doing better. But insight might tell you how to plan for catching the next swell, the next big wave that's coming, for example. And beyond that, you might have wisdom. And wisdom would be to question what you're doing and figure out whether you might be, maybe you should be doing something different. Maybe you're doing the right thing. That'd be wonderful. But it takes wisdom to see beyond the thing that you're occupied with and to adapt to that. Now, for most of human things, we are somewhere in this, things are happening to us, they produce signals, we get them, and we do things with them. And humans are pretty good at making information out of data with our brains, and we're pretty good at making knowledge out of it. Insight's harder. Wisdom's really hard, but I'm sure every one of you has encountered wisdom at some point in your life. I keep on hoping that I will. And because I don't believe in closed axes to any graph, somewhere out there, there may be something beyond wisdom that we may or may not have encountered before. I'm pretty sure that we could discover this if we were to invest in it. So what do I mean? Things are happening. Again, I said they're producing signals. So if you want to extract data from signals, we've evolved a lot of ways to do that, from having tentacles and eyes and hands so we can manipulate objects, to building things with our hands that can interact with the environment in ways that we can't, or to record these interactions. The Chinese were able to capture earthquakes and find out what direction they came from many hundreds of years ago. You can extend your sensing capabilities by persisting information, for example, by putting out a bucket to catch rain, and afterwards you can say how much it rained even though you weren't there. And for my business, we also use radio waves as a way of, we capture the signal of radio waves and turn that into data, and we can use that to look at distant stars and planets, but we can also put satellites out in space and use those to look at the Earth. So we're really, really good at producing lots of data, but once you have all that data, you still have to do something with it. Now, it used to be that you'd either have to be really smart and look at data and recognize trends, or you'd have to program. So here I have a really ugly bash script, and what it does is it scrubs some metadata from EXIF tags in order to sort that into the sorting algorithm of some program. Who cares? It's not very readable, it's not very fun, and it's definitely not reusable. But this is the old world. And many of you will be familiar with the newer world, which says we can take algorithms and use them straight out of the box. So give me some vectors out of this point cloud, or take this collection of reflectances that I have on a matrix and extract from that the edges and use that combined with contrast information and color to identify bird, flower, sky. Actually, there are no flowers here, but there is a tree. So these the algorithms now exist to take information out of data. And we can also go on abstracter levels. We can identify objects in a picture, which is fairly advanced and abstract. And we can even extrapolate from an image, not only the objects that are recorded in the image, but also additional things. For example, the emotional state of a person in a photograph. So this might be insight, depending on how you categorize it. I'd call that insight. So we're moving from signal to data to information. And if we're talking about knowledge, this would be something that's applicable for doing what we are doing at the moment. I'm not going to go into any of these algorithms because you know the algorithms, I'm sure, but just as a way of examining these things, ones that you'll know will be simple predictive analytics like linear or polynomial regressions, and you can use that to answer questions like how many rockets do I need to reach orbit, or will it rain today given the weather situation that I'm observing, or if I ask this person for their phone number, will they give it to me given their facial expression. And this goes on in your head all the time, and we've become pretty good at training machines to do this. Same thing with classifiers. These are algorithms that differentiate between different groups of things or group different things together, or look for sets and try to identify how many groups there are. So these are good for questions like, what am I looking at here? Is this a snail or is it a glacier? Or is it a muffin or a dog? Or I see there are animals, but are these animals dangerous? Probably in this case. And then of course, there are neural networks. So neural networks chain these together. All these different algorithms use weights to steer information as it moves through the network. And yeah, the inspiration is, of course, biological systems. So there's a lot to indicate that a brain is basically a big neural network using a lot of different information processing strategies to help us live our lives. And we can use neural networks in our brains and also in machines to answer questions like, how do I hike down to this lake without getting poison ivy or breaking my neck? Or if I have this receipt, how much should I tip the waiter? Or take a look at this picture and tell me if the person is bored. So these are all ways to do things that we do better. Where does the insight come in? Well, insight is normally slightly more advanced. So we use insight to plan for the future. And we have managed to do this with machine learning. So there are a lot of really cool applications out there that are doing things like optimizing traffic systems, also anticipating demographic change and putting these things together to try to make better cities. Or they might be looking for faster ways of classifying genes to find good medications. Or they might be used in contexts where human intervention is not practical, like on other planets. You have really slow communication, so you need a robot to be able to act on its own in a very, very limited question. So I would really hope that the Curiosity rover is not questioning the wisdom of what it's doing. I really hope that it's just worrying about tactical questions like, how do I sample this rock? And that is in the area of insight and not in the area of wisdom or anything beyond that. So most of the things that we work on in a day-to-day basis are in this area. Capture the signal, turn it into data, pull information out of that, and extract knowledge so that we can optimize our business flows. At least that's my day-to-day. But I like to think about the questions of how do I anticipate how my business is going to change and how my needs are going to change, and adapt to those and be ready for that. So if I'm at my job and I'm doing a really good job with my software engineering and data formats engineering, I'm not only taking out knowledge from the data I look at, but I'm also anticipating changing needs and optimizing what I'm doing right now so that it matches our needs in the future. And on top of that, I might say, why am I doing this thing? Is it the right thing? Are we going in the right direction? Or are we not? In my personal life, this becomes even more important. And when we're thinking about revolutionizing our society and the way we live as humans, moving forward in this very young millennium, that's one of the more important questions. We're very, very good at producing value. We're not that good at distributing value. And we optimize for certain things which may not be good for us in the future. So what should we be changing about that? And so in this context, now for me, I'd like to see if anybody has any additional thoughts to these things. What can AI and big data bring us for the future beyond doing what we're doing, but better? Any ideas? Okay, this demonstrates the fact that the farther to the right you go in this diagram, the harder it is. So I know you're on the spot, and I don't have any really genius, wise answers, but I see maybe you do.
Yeah, like maybe society changes and change the way maybe, for example, like with climate change and those aspects, how to support people in, yeah, maybe change their personal behavior.
Mm-hmm.
Yeah, like living around with the nature and how you act more in not like this whole world with the nature, for instance. Yeah.
Hmm. Hmm.
This is not such a technical aspect, but I mean, a lot of humans are driven by their daily work and how they behave. And for a lot of people, if they reach a certain age, they don't change a lot anymore. And that is probably, yeah, I mean, it's not, it's typical human, but maybe AI can help maybe finding new opportunity for those humans as well.
Yeah, a lot of times it's really hard to know the impact of what you're doing as well. And nobody has the time or the energy to catalog every single sequence of a given searches, for example. So AI could help with that, for example. I think that was another hand back there.
Yeah, maybe to work together with social scientists and find flaws in society and how we live together and find optimization potential or other things in that area.
Yeah. Does anybody know what the proportion of investments in research went into the social sciences worldwide as compared to natural sciences? I don't, but it'd be an interesting question. There was one back here somewhere too, I thought, maybe. No? Okay. Okay, well, I'm going to write those down, and then I'm going to get off the stage so that we can talk and drink beer. But I think that's very interesting. Nature, society, understanding impacts. Does that capture what you were talking about? Okay, big questions. Humanity has been trying to tackle these big questions for thousands of years, but we've never had as many minds as we do now. We've never had a big cloud that we could use for it. So I think that we have potential there. And I would hope that maybe some of you take these ideas and can apply them in a way that goes beyond doing what we're doing, but better. Thanks very much.